So for this video, we'll be talking about decimals and how to convert decimals into fractions. So first, let us define a little bit what decimals are. So from the word here, deci, which literally means in math as 1/10 or 1/10. So from this idea, we see that decimals are numbers that represents fraction where the denominator is a power of 10. So let's give a example on that. So if we have 12.3, we can write this one as 10 plus 2 plus 3/10. We can still, if we still want to add another number here, we can write that one as 4/100. And if we add another number here, we can write that as 5/1000. So as you can see, these numbers in the denominator are 10⁻⁻1, 10 squared, 10 cubed. So basically, this is how decimals work. In this fraction 3/10, in decimal form, we simply write it as 0.3. This 4/100, we simply write it as 0.04. And this for 5/1000, we simply write it as 0.005. Since we can write this one as 0.3 plus 0.04 plus 0.005. So that is a brief overview on how decimals work. Now let's start on in converting decimals to fractions. So let's first have this example. If we have 0.25, how do we convert this into fraction? Now we note that we can write this one as 0.25 all over 1. But note that 1 can be written as 1.00. Indeed, we can write 1 as 1.0, 1.00, 1.0000. How many zeros is that? Since these zeros are simply 0/10 or 0/10 plus 0/100, which are simply 0. So that is the idea behind. So now, what we do next is we can multiply this fraction by 100/100 to remove the decimal portion. Or simply, in decimals, we view that as moving the decimal point. So in this one, we'll move this decimal point twice out here. Since we move it twice in the numerator, we also move it twice in the denominator. So this would give us this would give us 25/100, which is equal to 25 times 4 over 25/25 times 4, which we could cancel the 25 out here, leaving us with 1/4. And that is how we can convert decimals to fractions. Let's try another example, but this time we would speed up our solution since we already know the minor details behind this. So for this, we have 0.125. So this, we could write this as 0.125 all over 1.0 0, 0, 0. So we can move the decimal place out here 3 times. This would give us 125 over 1000. And note that this one is actually divisible by 25, both of them. So this one is equal to 25 times 5. Yep. And this one is equal to 25 times 40. So from here, you can cancel out the 25, leaving us with 5 over 40, which can still be further simplified in 5 over 5 times 8, canceling the 5 out here, would give us with 1 over 8. So 0.125 is equal to 1 over 8. For our third example, let's have this one, 1.30. Now for this one, we have 1.30 all over 1.00. Just a quick note, if you still haven't noticed it, we choose the version of 1 in the denominator based on the decimal places in the numerator. So in this case, we have 2 decimals. So this one will give us 0.00. So that when we move this one, we would obtain 130 over 100, cancelling out the 0 in the last portion would give us 13 over 10, or in mixed numbers 1 and 3 over 10. So that is how we can convert decimal to fractions. Now what if we have this example? What if we have 0.123, 123, 123, 123, and so on? So for this case, this decimal is what we call a non-terminating decimal or repeating decimal, since as we can see, this 3 repeats endlessly or infinitely. So how do we deal with this one? Now first note that we can write this one as 0.123 with a bar on top. This bar simply refers to that these numbers are the one that repeat. So to convert this into fraction, this would simply be equal to 123 over 99. So the reason behind that is that 123 in here refers to the group of repeat. So in this case, this is the 3 numbers that are repeat, and the 999 comes from the number of the repeating decimals. So in this case, we have 3 repeating decimals, and we convert those to nines. So it becomes 9, 9, and 9. So that is simply how we convert a repeating or non-terminating decimal into fraction. So we can still further simplify this into 3 times 41 all over 3 times 333. Cancelling out the like terms would leave us with 41 over 333. So take note of this answer, since I would show just a small proof on how we arrive with that idea. Proof. So first, let us let x equals 0.123, 123, and so on. So this one, we can multiply 1000 both sides, which would give us 1000x equals 123 0.123, 123, and so on. So now we can view this decimal as x, since it's this one. So we can write this one as 1000x equals 123 plus x. So we can move this x out here, which would give us 1000x minus x equals 123, which is equal to 999x equals 123, which would arrive us with x equals 123 over 99, or in simplest terms, would give us this one. So that is how the idea behind using 999 in the denominator works. So let's have one final example. If we have 3.454545 and so on, or since we know that the 45 is the one repeating, we can write this as 3.45 with a bar. So this one is equal to 3 plus 0.45 bar, or as we know, that's simply equal to 45 over 99. So observe here that we only have two 99s here, two 9s here, since the number of repeating decimals is only 2. So this one and this one. Now note that we can still simplify this as 3 plus the above is 5 times 9 all over 11 times 9. And that would give us, cancelling these two, would give us 3 plus 5 over 11, or 3 and 5 over 11 in mixed numbers. And so that is our final answer. If you want to convert it to improper fraction, you can simply multiply this and add this. And for verification, that is simply 38 over 11. Yep. And so that is how we convert decimals to fractions. So we start off with converting basic decimals to fraction, or these are decimals that are non-terminating or repeating. And then we follow with decimals that are non-terminating or repeating, since there's somewhat a trick on how to convert these into fraction. And so that is all for this video.